my KCET 2026 aspirants, so welcome to the Sankalp batch 2026, and in today's class we are going to solve the previous year questions of the chapter solutions. So we have already done KCET PYQs, we have already revised the concepts and we have studied so many formulas, and now let's check that whatever we have studied, can we use that in JEE questions or not, right? Whether these formulas are applicable, because there is a hype, right? JEE is very difficult, JEE is very difficult, but can we crack questions if we have the foundation strong, if our basic concepts are clear? Can we do that? So let's check out, and today I'll be solving 20 questions from JEE 2025 paper of different shifts. I have mentioned them also, so you can use that to refer to the questions, and you have to solve the question with me or you can solve it by your own and check the answer. And after that I want all of you to comment how did you feel the session, how was the JEE paper, JEE questions. I know it will be little lengthy, but can we solve it whatever time it takes, because we are in the initial phase. Don't worry about speed, time, anything. Are we able to solve the questions or not? That should be our priority. Okay, I'll be telling each and every step, very detailed calculations, everything we'll be doing, so please watch the complete video, right? Okay, let's get started here with the first question. So in JEE exam we get two types of question, one is MCQ type and one is numerical answer type questions. So whenever there is numerical answer type questions, I would strongly recommend to not to do any rounding off or not to guess any calculation, because you have to be very particular with the answer. So I want all of you to solve either divide, division, multiplication, to do it correctly and completely. Don't do any round off here. That would be my suggestion, because I tried solving them while doing round off. The errors are coming, so that is from my experience. Do not repeat that. Okay, so first question here, sea water, okay, which can be considered as a 6 molar solution of NaCl. So we know that in sea water there is salt, so there is 6 molar NaCl, means 6 moles of NaCl is present in 1 liter of water, right? Has a density of 2 gram per ml. The concentration of dissolved oxygen in sea water is 5.8 ppm. So there is also oxygen dissolved in that water, 5.8 ppm. Then the concentration of the dissolved water in the sea water, dissolved oxygen in sea water, is x into 10 to the power of -4 molal. Okay, so the question, so first let us understand diagrammatically this question. Okay, you have here, let this be sea water. Okay, so what is this? This is your sea water, and in this sea water what we have? We have NaCl, right? So I have NaCl here. So these yellow particles you can see, NaCl is dissolved. So what is the concentration of this NaCl, it is asked? The concentration of NaCl in sea water is 6 molar. Okay, and we also have dissolved oxygen in this. So I will denote oxygen with white water, with white balls. So we also have dissolved oxygen in this, and the oxygen concentration is given to me in the form of ppm. Okay, so the question is now being asked, what is the molality of this oxygen in the sea water? The question is to find out molality of oxygen in sea water. Okay, that is the basic question being asked here. So we know the formula of molality, so let's put down first the formula of molality. What is the formula of molality here? We have here, just a minute. Yeah, so what is the formula of molality here? Molality is, see, mass of oxygen divided by molar mass of oxygen right, into 1000 by mass of the solvent. Okay, mass of oxygen by molar mass of oxygen into 1000 by mass of the solvent, right? This is the formula. So what all data I know? Here I know molar mass of oxygen, that is 32, we know oxygen gas 32 molar mass I know, but I don't know what is the mass of oxygen present, and I also don't know the mass of solvent present. Okay, let's first calculate these two and then put down in this formula and get the solution done. So first let us try to find the mass of oxygen here. So what is the about oxygen, what information we have? It is 5.8 ppm. Okay, so what is the formula for ppm? Mass of the solute by mass of the solution into 10 to the power of 6. So I also don't have the mass of the solution. See, if I want to find out ppm, what is the formula of ppm? Mass of solute by mass of solution into 10 to the power of 6, right? So mass of the solution also I need. I have to find this one, mass of the solute, right? I have to find this mass of the oxygen here, or let me just write down mass of oxygen instead of solute so that it will be more clear, right? I have to find mass of oxygen, mass of solution I have to find out, and ppm is given to me. So I also need this mass of solution in order to calculate the mass of oxygen. So what we can do that for? So I have been given with this 6 molar solution. What do you mean by 6 molar solution? For NaCl, okay, or just let me tell you that what is the volume? 6 molar means what? 6 molar NaCl means 6 moles of NaCl in 1 liter of solution, right? So what is the volume of NaCl? That is 1000 ml. Okay, and what is the density here? Density of NaCl is 2 gram per ml, right? So I have volume of this is volume of not NaCl, it is the volume of the solution, right? Volume of solution, density of solution. So can I calculate from here mass of the solution? Right, we know that is a relation, density is equal to mass by volume. So mass will be volume into density. So I can write mass of the solution equal to 2000 grams, right? So in this 2000 gram of solution, there is 6 molar NaCl, means 6 moles of NaCl is present. So I can calculate mass of NaCl, right? Mass of NaCl I can calculate. What is that? 6 into the molar mass of NaCl is 58.5. Okay, if I solve this, I will get 6 5s are 30, 6 8s are 48 plus 351, 5 35, 351. So in the total solution of 2000 gram, what is the mass of the solution? Mass of NaCl 351. So I have total solution is 2000 gram and I have this mass of NaCl is 351. Then from here can I calculate mass of the solvent? Mass of the solvent, mass of the solvent. Okay, so mass of the solvent will be equal to how much? 2000 into 351. Okay, so I have 10 minus 1 9, 9 minus 5 4, 9 minus 3 6, and I have 1. Okay, this one is there and I have 2. So total mass of the solvent is 1649, which I required here. Mass of the solvent I got, but still I need this mass of oxygen. Okay, so now can I substitute here? I got ppm data is there, mass of the solution I got, and 10. So can I calculate mass of oxygen here first? So let's do that, and I'm removing this calculation here. I want all of you to copy down this one, or let me, okay fine, let me solve it here. What is the mass of oxygen? So ppm is how much? 5.8 ppm. Okay, is equal to, let this mass of oxygen I have to calculate, and I have mass of the solution 2000 into 10 to the power of 6. Okay, so I have this one, 2 8s are 16, 2 5s are 10 plus 1 11, that is 11.6. yeah, then I have 11.6 into 10 to the power of minus 3, so that becomes 0.0116. I'll just write down directly. I have here 0.0116. That is the mass of oxygen. So till now whatever things we have done, let me revise it once again. So I want to find the molality of oxygen. So what is the formula of molality of oxygen? Mass of oxygen by molar mass of oxygen into 1000 by mass of the solvent. So I have this molar mass of oxygen only, which is 32, but I don't know what is the mass of oxygen and what is the mass of the solvent. So first, to find out the mass of the solvent, we have done this operation. What I have done here, so there is, since it is 6 molar solution is given, that means volume of the solution is 1 liter. Volume of the solution is 1000 ml, 1 liter or 1000 ml. Why? Because molarity is there. Molarity means what? Molarity means 6 moles in 1 liter. 1 liter means 1000 ml. Volume of the solution I got. Density of the solution is 2 gram per ml. Okay. Then what is the mass of the solution? Density into volume, that is 2000 gram. So I got mass of the solution is 2000 gram. Next I have mass of NaCl. Mass of NaCl is 6 into 58.5. So I have 6 5s are 30. Here I'll multiply. So total mass of the solute or mass of NaCl is 351 and mass of the solution is 2000. So what will be the mass of the solvent? 2000 minus 351, which is 1649. Okay, this is the mass of the solvent, 1649. Now here I have got this value, which is 1649. I have still pending with this mass of oxygen. So what is the formula for ppm? Mass of the solute by mass of the solution into 10 to the power of 6. Now mass of oxygen is 32. Sorry, mass of the oxygen I have to find out. Mass of the solution is 2000. You can see the mass of the solution is 2000 into 10 to the power of 6, and ppm given to me is 5.8. Now if I solve this, I'll get 0.0016. This is your mass of oxygen. Right. So now you see, I have found mass of oxygen, I have found mass of solvent, and I know the molar mass of oxygen, and I just calculate this one to get the molality value. Right. So let's do all this calculation here. I'll erase this all thing from now. Okay. So let me just erase this one. So here I have, first of all, mass of oxygen. Mass of oxygen I got was around 0.0116. Okay. Then I have mass of the solvent. Mass of solvent, which is equal to 2000 gram. Sorry, mass of the solvent was 1649. Right. 1649. Now I'll calculate molality. Mass of oxygen is 116 into 10 to the power of minus 4 divided by 32 into 1000 by 1649. Okay. So now if I solve this, I'll get 11.6 into 32 into 1649. 4 plus 3 minus 1, I got 11.6 by 32 into 1649. Now I have to solve this. Okay, so here I am telling you, don't do any approximation, try to do as much calculation as you can do. Okay, I know it is little bit difficult, but yeah, you have time, 25 questions, 1 hour, you have to use it in this calculations only. So if I do, I'll have 2 6s are 13, 16 2s are 32, and I have 2 5s are 10, 5.8, right? Next I can have 5.8 and 16, I can further cancel, 2 8s are 16, and I have 2.9, right? So I have 29 by 80 into 1649. Okay, so if you solve this, now if you solve this, you will get 0.000219. Okay, so the question is asked dash into 10 to the power of minus 4. So what is this x value then? You can see it will be 2.19, and to the nearest round of, if you see the nearest integer, it has to be 2. Okay, so this is the calculation, and I hope you can do this calculation, normal division, but you have to do it carefully. Fine. Next we'll move to the question number 2 here. this is a very good question. Fortification of food with iron is done using FeSO4.7H2O. Means if you want to inculcate the value of iron to any food, we add FeSO4.7H2O. Now the mass of grams of FeSO4.7H2O for required to achieve 12 ppm of iron in 150 kg of wheat is. So again let us imagine I have 150 kg of wheat. Okay, so total wheat I have is 150 kg, and what I have to add here, I have to add Fe. Okay, such that the final concentration of Fe is 12 ppm. Fe is 12 ppm, right? Now what happens? Now I have, okay, Fe is 12 ppm, 150 kg of wheat is added to that. Next what I have here is the molar mass. So the question is here, like how much FeSO4.7H2O, okay, how much of this one should be added to this wheat so that I'll get 12 ppm of Fe. So this FeSO4.7H2O has Fe, right? So the question is asked, how much gram of FeSO4.7H2O is to be added to 150 kg of wheat so that the final concentration of Fe becomes 12 ppm. Okay, I hope this question is clear. So we want 12 ppm of Fe, and for that how much FeSO4 I have to add. Okay, so first let us calculate for getting 12 ppm of Fe, how much Fe has to be added. Okay, so first let us calculate amount of Fe needed for 12 ppm, right? So what's the formula here? You know, ppm is equal to mass of the solute, right, divided by total mass of the solution into 10 to the power of 6. Now here ppm required is 12. Okay, mass of solute here means I have the mass of Fe, right? So I'll mention it as Fe. So that I have to calculate, divided by wheat mass is 150 into 10 to the power of 3. Kg is there, convert it into grams, and then I have 10 to the power of 6 here, right? So now if I solve this, I will have 12 into 150, okay, divided by 10 to the power of 3. Yes, okay. So now I have this one. If I solve this, 12 into 15 is, I have to just solve, let me solve it. 12 5s are 60, 6, 12 1s are 6 plus 18, right? So 12 into 15 is 18, 180, and I have 0, and then below I have 3 zeros. So I will get 1.8 grams. Okay, so how much Fe is needed? 1.8 gram of Fe is needed to get 12 ppm of Fe in 150 kg. So now how much Fe is needed? I have got 1.8 gram. But this Fe will be obtained from where? This Fe will be obtained from FeSO4.7H2O. So now the question is arising, how much FeSO4.7H2O is to be added so that I'll get 1.8 gram of Fe. Okay, so now this is the second part of the question. So first let's calculate the molar mass of FeSO4.7H2O. Fe mass is 56, that is given to us all the molar masses. Sulfur is 32, oxygen is 64, okay, and here we have 18 into 7, 126. 6 plus 6, 12 plus 4, so I'll just 6 plus 4, 10, 11, 12 plus 6, 18, I have 1, 6 plus 3, 9 plus 1, 10, 15, 16, 17, 1, 278, okay. 6 plus 6, 12, 12, 16, 18, 1, 6 plus 3, 9, 10, 15, 17, 1, 278. So total mass of FeSO4.7H2O is 278. Now here we have this one is, now in 278 gram of FeSO4.7H2O, okay, in 278 gram of this one, I have how much gram of Fe? I have 56 gram of Fe, right? Or I can say that, and I can say that 56 gram of Fe is produced or is obtained from 278 gram of FeSO4.7H2O. So for 1 gram of Fe, how much it will be? 278 by 56, and I want 1.8. So for 1.8 gram, how much it will be? 278 by 56 into 1.8. Okay, so I have 2 9s and 2 28s. Okay, next I have 2 14s and 139. 139 into 14. Okay, next I think now we have to do the calculation. So I have this, I will use this area, 139 into 9 divided by 14. Okay, any other I can reduce? I don't think so. 278. Okay, so 9 9s are 81. So I have 139.9. I am multiplying here into 0.9. So I have 9 9s are 81. 8, 9 3s are 27 plus 8, 35, 3, 9 1s are 9, 10, 11, 12. 125.1 divided by 14. Okay, so let's divide this one. 125.1 divided by 14. Okay, so I have 14, 8 4s are 32, 8 1s are 8. I can have 14 8s are, right? 8 4s are 32, 3, 8 1s are 8 plus 3, 11. So 5 minus 2, 3, I have 2 minus 1, 1. Then again I have 131. Then I have 9 4s are 39, I can go. So almost it is equal to 8.9, right? So this is almost equal to 8.9. And if it is 8.9, then the nearest whole number for that will be, nearest integer will be equal to 9, right? So the answer for this will be answer 9. Okay, next moving to question number 3 here. This is also a very good question. 10 ml of 2M NaOH is added to 20 ml of 1M HCl solution kept in a beaker. So I have what? 10 ml 2 molar NaOH solution, okay, and 20 ml 1 molar HCl solution, okay, in a beaker. Now 10 ml of this mixture is poured in a volumetric flask of 100 ml containing 2 moles of HCl. 10 ml of this mixture is poured into a volumetric flask of 100 ml containing 2 moles of HCl. Okay, so I have now first let me see if you have remembered the molarity formula. What is molarity? Number of moles by volume in ml into 1000, right? Now if I want to just calculate number of moles, what I will get? Molarity into volume into 10 to the power of minus 3. So I can say that this value into 10 to the power of minus 3, right? So that will give you number of moles. Now this one will, you can take it as a unit of millimoles, right? If suppose I have this one, I want to convert it into millimoles, then I will multiply with divided by 1000. So that is whatever answer I will get, that is millimoles. So I can say that here millimoles of NaOH is equal to 20 into 20. Millimoles of NaOH is 20. Next I have here millimoles of HCl. Okay, then that will give me 20. Right? Now see, NaOH and HCl, these are strong acid and strong base, so they will neutralize each other. So 20 millimoles of NaOH will react with 20 moles of HCl and the solution now is neutral. Okay. Now what we have done, so in this chamber or in this flask, you can see now I have 20 ml and total 30 ml is there. Okay, 30 ml of solution is there, and in this 30 ml now I have 20 millimoles of NaCl. Okay, because NaOH and HCl will react to give you what? NaCl. So in this flask now this is present. Next what is done? 10 ml of this mixture. Okay, 10 ml of this mixture is poured into a volumetric flask of 100 ml containing 2 mole of HCl. So now what happens? See, I erasing this one. You will see how confusing this question was and actually how easy it is to solve. See, now what we have done. Okay. Now what is there? We have a volumetric flask. Okay, you have a volumetric flask. It is like this. Okay, a volumetric flask of 100 ml is there. Okay, a volumetric, now 10 ml of this solution is poured into a volumetric flask of 100 ml containing 2 moles of HCl. So there is 2 moles of HCl here. Okay, and what you have done, you have taken 10 ml of this solution and added here. Okay, this 10 ml is added now here. Clear? Now what happens? Okay, now what happens? And made the volume up to the mark with distilled water. Okay, so now this is, we have added water to this one. You have added water to this one up to 100 ml. Okay, up to 100 ml you have added water to this. Next, what happens now? You have to tell the solution in the flask is. So now there is NaCl is there. Okay, but this NaCl is neutral solution, right? So we have here 10 ml. You have taken how many? So what is the molarity of NaCl? Can I just calculate the molarity of NaCl here? Number of moles is 20 into 10 to the power of minus 3 divided by 30 into 3. This will get cancelled. 2 by 3 is the molarity of NaCl. Okay. Now what happens? So now that is not being affected anyway, but HCl is there. HCl 2 moles was there. Now it became 100 ml solution you have added. Total volume you made 100 ml. So what is the molarity of NaCl? Molarity of HCl. So 2 moles of HCl into 1000 by 100. So I'll just cancel this one. Why am I taking 100? Because the total volume is 100. So it becomes 20 m HCl. Okay. So NaCl, this part is definitely not correct, right? So we can exclude this option. 10 ml is wrong, right? So that is the option number B here. Next, question number 4. X gram of NaCl is added to a water in a beaker with a lid. Okay, X gram of NaCl is added to water in a beaker with a lid. So you have a beaker with a lid. Okay, it has some water and you have added X gram of NaCl. The temperature of the system is raised from 1 degree Celsius to 25 degrees Celsius. Okay, so temperature of the system from 1 degree to 25 degree you have raised. Which out of the following plots is best suited to change the molarity of the solution with respect to temperature? So if you see molarity equal to what? Number of moles by volume. And when you increase the temperature, what happens? Volume will also increase, and if volume increase, molarity will decrease. So molarity has to decrease. We have this option and this option eliminated because here the molarity is increasing. Now coming to these two equations. So if you remember, for the density of water is 4 degrees Celsius, right? So up to 4 degrees Celsius, what will happen? The molarity will increase, but after the density of water is reached, after that when you increase the temperature, the molarity curve will decrease. So that is why first of all up to 4 degree, okay, there will be a slight increase and then it will decrease. So option number B here and not D. Okay, fine. Next, question number 5 here. Density of 3 molar NaCl solution is given. The molality of the solution is. This type of question is very easy. Children remember a lot of formulas, but I don't prefer remembering formula for this type of question. You should understand the concept here. Okay. So now just see 3 molar NaCl means what does that tell me? Volume of NaCl is how much, or volume of the solution is how much? 1 liter, or I can write 1000 ml. Then I have density of the solution. Density is equal to 1.25 gram per ml. Okay, mass of the solution I can calculate from there, right? Mass will be what? Density into volume, so 1250. Okay, next we have okay, what is the mass of the solvent? Mass of the solvent is 58.5 into 3. 3 5s are 15, 3s are 24 plus 1 25, 15, 16, 17, 175.5. So I can say that mass of NaCl is 175.5. So what is the mass of the solvent then? This is the mass of the solute, total mass of the solution, 1250 minus 175.5. So I have 10 minus 5 5, 9 minus 5 4, 14 minus 7 7, then here it will be 1 minus 1 0, 1074.5. So let me just recheck the calculation. Yes, 1074.5 is the mass of the solvent. Now if I want to calculate molality, okay, so I have 3 moles of NaCl. So what is, so this 3m denotes what? 3 moles of NaCl in 1 liter of solution, right? So what is the moles of NaCl? 3 moles. So I have molality, number of moles is 3 divided by mass of the solvent, that is 1074.5 into 1000. So if I just see, I can write this one as 30,000, just 30,000 divided by 1074 and 5. Okay, 30,000 divided by 1074.5. So now let's calculate this one. Okay, we have this one, 30,000 divided by 1074 and 5. So we have here 2, I can take first 2, 5s are 10, 2 5 4s are 8 plus 1 9, 2 7s are 14, 2 zeros are 0 plus 1, 2 1s are 2. So 0, 10 minus 9 1, 9 minus 4 5, 9 minus 1 8. Okay, then again I have this one. So here if I see, I can take 7, right? If I take 8, it will become more, 7 point something, 2.79 I will get, which is your option number B. After getting 2 decimal, you can easily guess the answer here, right? So this one will give me 2.79. Okay, molal. Moving to the next question here, 20 ml of 2 molar NaOH solution is added to 400 ml of 0.5 m NaOH solution. The final concentration of the solution is. Okay, so first of all we have one solution, this one, that is 20 ml 2 molar NaOH. So as just now I have discussed how to calculate the number of moles, number of millimoles you will get, number of millimoles will be equal to molarity into volume. So that is 40 millimoles. Okay, next we have what? 400 ml 5 m NaOH, 400 ml 0.5 m NaOH. So if I multiply this one, I will get 200, right? 200 millimoles, right? So what is the total number of moles? N total is 200 plus 40, 240 millimoles. N total is this much. What is V total? V total is 400 plus 20, 420. Okay. Now what I have to calculate? Final concentration or molarity. Okay. So molarity is equal to number of moles, that is 240, volume, that is 420, into 1000. Okay. So now we can solve this one. 6 4s are 24, 6 8, 6 7s are 42. So I have 4000 by 7. Okay. So just let me check once again. I have to calculate what? Molarity, right? Okay, here volume total is 420. 400 plus 20, 420. Total number of moles is 240. 240 by 420 into 1000. Yes, that is correct. So I have cancelled 6 4s are 6 7s are. So I have 4000 divided by 7, right? So let's divide this one. 4000 divided by 7. Okay, so I have 7 5s are 7 6 is 42. 7 5s is 35. I have 50. Then I have 7 7s are 49, or I have 110. 7 1s are 7. Then I have 3. I can take 7 4s are 28 something. So you have to find how much will this come. So if I take this one, so molality I am getting is 571.4, right? Now we have dash into 10 to the power of minus 2. Okay, I missed one more thing, I think. Just a minute. Okay, it is, we'll convert it into moles as well, right? So 240 into 10 to the power of minus 3 moles. So here I will have one more 10 to the power of minus 3. This will get cancelled. So I have only 4 by 7. Okay. So here I made a mistake. I have just 4 by 7. Okay. I hope you are getting. Once again, see here. The millimoles, total millimoles was 240 millimoles, but I have to convert them into moles. So 240 millimoles to moles is 240 into 10 to the power of minus 3 moles, then divided by volume. Since the volume is in ml, you are multiplying this 1000. So this 1000 will get cancelled. So I have just left with 4 by 7. So I have to do here 4 by 7. I hope this is clear. 4 by 7. So here again 7 5s are 35. I am left with 5. So 7 7s are 49. So I will have 57. So or 0.57. This value is coming 0.57. So answer will be 57 into 10 to the power of minus 2, or that will give me 0.57. Okay. Next, the molarity of a 70% mass by mass aqueous solution of a monobasic acid X is 10 to the power of minus 1 molar. Density of the solution is given, molar mass of the acid is given. So what we have to find out? We have to find out the molarity. So first of all, 70% mass by mass. What all data this gives us? So first see here, if I have 70% mass by mass. Okay. So what is the acid X? Okay, the molarity of a 70% mass by mass aqueous solution of a monobasic acid X is. So if I have monobasic acid X, right? Okay. So what is this mass of X? That means it is 70 gram. Mass of the solution 100 grams. Okay. So I have aqueous solution of a monobasic acid 70 gram, mass of the solution is 100 gram. Density, okay, so we have been given with a density of the solution. What is the density of the solution given to me? Density of the solution is 1.25 grams per ml. Okay. Next you have molar mass of the acid. So molar mass of this acid is also 70 grams per mole. So I have mass of the solution, density of the solution. Can I calculate volume of the solution? Mass by density 100 by 1.25. Okay. Next we have here molality. Okay. Molality is equal to number of mass of the solute 70 by molar mass of the solute 70. Okay, grams per mole into 1000, okay, by 100 by 1.25. Volume I am putting as 100 by 1.25. Okay, so that will cancel these things. Okay, and I will just get 12.5. right? So I'm getting 12.5 means I can write it as 125 into 10 to the power of minus 1. So what is the nearest integer I'm getting? 125. 125 is the answer. Clear? Let's move to the next question. Concentrated nitric acid is leveled as 75% by mass. Again, that means what? What is the mass of nitric acid? Mass of nitric acid is 75 grams. And what is the mass of the solution? That is 100 grams. Okay. The volume in ml of the solution which contains 30 gram of nitric acid is the volume in ml of the solution which contains 30 gram of nitric acid is the volume in ml of the solution which contains 30 gram of nitric acid. So we have to find out that volume of nitric acid or that volume of the solution in which 30 gram of nitric acid is there. So how much volume of the solution will contain 30 gram of nitric acid? So density of nitric acid is given here. Density of the solution is also given to me is 1.25 grams per ml. So now what I can say is for 75 gram of nitric acid, what is the mass of the solution? 100 gram is the mass of the solution. Right? In 100 gram, 75 gram of HNO3 is present. In 1 gram of for 1 gram of HNO3, how much will be the solution? 100 by 75 solution. Okay. Next for 30 gram, that is your 75 gram, 1 gram, and then I have 30 gram of nitric acid. $100 by 75 into 30. 15 2s are 30, 15 5s are 75, 5 1s are 5 2s are. I have 40 grams of the solution. Okay, so what is the mass of the solution I have? 40 gram is the mass of the solution. So if I have now 40 gram, what is the density of this solution? So if you know, I want to calculate the volume, right? So I have this formula, density is equal to mass by volume, or I can write volume is equal to mass by density. So what is the mass of the solution is written at 40 grams, okay, and the density that is required is 125. Okay, so I will have 40 by 125 is 100. Okay, so I have 25 4s are 25 5s are 5 1s are 5 8s are, and that will give me 32. So what will be the answer here? 32. The volume in ml is 32 ml. Okay, so first we calculated 30 gram of HNO3 will be present in how much mass of the solution, and that mass of the solution we are converting into volume by multiplying or by using the density formula. Okay. Moving to the 9th question here. So now we'll go to the next topic, that is solubility and vapor pressure concept. Okay, so the first question, this is also very interesting question. Liquid A and B forms an ideal solution. Okay, the vapor pressure of pure liquid A and B are 350 and 750. So what is the vapor pressure of pure liquid A? 350, and pure liquid B vapor pressure is 750. That means what? B is more volatile, means B is creating more vapor pressure, B is more volatile. Okay, so this give me a conclusion that B is more volatile, right? Because it is creating more vapor pressure, it can easily evaporate. That means it is more volatile than A. If XA and XB are the mole fraction of A and B in the solution, while YA and YB are the mole fraction of A and B in the vapor phase. So if I haven't discussed, I don't remember, let me just tell you here. So when you have a Raoult's law we have studied, right? So when we have two particles, okay, this is one particle and I have another particle, for example, let me take this color. Okay, both of them will evaporate, right? So suppose this one has evaporated like this is the vapors of B and these are the vapors of A. Okay, so XA and XB represents the mole fraction of A and B in the solution. Okay, inside the solution how much A and B is present, and YA and YP represents the vapor pressure of A and B in the vapor phase. Okay, when they are evaporated, how many moles of A has evaporated, or what's the mole fraction of A that has evaporated, mole fraction of B that has evaporated, right? Clear? So what is XA and XB, YA and YB? So this is XA, this is YA, okay, and I have this is XB and this is YB. Okay, clear this one. Next we will have the thing that is, okay, fine. Now what I can say, B is more volatile. So what does it give you? Now see, if B is more volatile, then I can say that B, more vapors of B would have been formed. So let us draw once again. I have erased it. Okay, let us draw here once again. Okay, B is more volatile. Okay, I am using green color for B, means more vapors of B will be there. Okay, more vapors of B will be there. Most of the B has evaporated. So in the solution, less B will be there, right? While comparing to A is less volatile, means A will have less vapor and A will have more number of moles in the liquid phase. Right? Can I conclude this one from here? A has less number of vapors because it is less volatile, it will be more present in the solute, and B will have more number of vapors and less in the solution. So can I conclude from here that this one, YA is less than YB, okay, YA is less than YB, and I have one more conclusion that XA is greater than XB. Okay, number of moles of A, mole fraction of A is more than the mole fraction of B. Mole fraction of YA is less than the mole fraction of YB. One more comparison that I can do between XA and YA, that XA is greater than YA. XA, see XA, this is XA is greater than YA, and I have YB is greater than XB. Can I get this one? XA, number of moles of A, XA, here this is XA, this is YA. Similarly, this is XB and this is YB. So I can say that XA is more than YA and I have YB is more than XB. Why this is all happening? Because V is more volatile. Now let's try to check this option. What I have here, XA by XB is less than YA by YB. So let's just cross multiply this one. I will get XA into YB is less than YA into XB. I can get this one. Now what I can do, I'll just take all the A terms to one side and B terms to one side. I can have XA by YA is equal or less than XB by YB. Okay, now see here, we have this XA is greater than YA, XA is greater than YA, right? That means this number will be more than 1. I hope you are getting this. Whenever you divide 5 by 2, the numerator, if the numerator is greater than the denominator, then we will have more than 1. If the numerator is less than denominator, we will get less than 1. So this number is more than 1, and XB by YB, if you see YB is greater, right, than XB. So it means it is numerator is small, denominator is big. So this value will be less than 1. Right? So can a more than 1 number, for example, let it be 3, and less than 1 number, for example 0.2, can this be less than this one? No, this sign is wrong, right? So that is why this option is incorrect. Okay, I hope you are getting this one. Very easy, just need to analyze it. Now let's go to the next question. Next option, sorry, is this giving XA by XB is equal to YA by YB? No, this is not at all possible, because for equality you need to have equal number of moles. That is not there. Now let's check this one, option number C. I'll cross multiply this one, XA YB, then I have YA XB. I'll take all the A terms to one side, XA by YA is greater than XB by YB. Right? Now see, YA is greater than XA, sorry, XA is greater than YA. So this number will be more than 1, this number will be more than 1, and this number XB, since it is less, XB by YB will be less than 1. So this number will definitely be greater than this number. So obviously this one is correct. Right? So I got the answer, that is option number C. If you check, this also is incorrect. Okay, fine. Now just let's see the next one. Okay, just I will check this option as well. See, XA is greater than YA. Okay, XA is greater than YA. So I will have, so this number will be a positive number. XA is greater than YA, so their subtraction will be a positive number. And since XB is less than YB, this subtraction, that is XB minus YB, will be a negative number. And a negative number cannot be greater than a positive number. So this is also incorrect. Okay, so option number C is the correct option here. Now let's see the 10th question. Okay, so this is a bit lengthy question, a calculation based question, but yes, I'll tell you how to do it. At the sea level, the dry air mass percentage is given as for nitrogen, oxygen and argon. So for nitrogen, oxygen and argon. Okay, so but you can see there are two questions asked here. If you solve any one, you will get the answer because all the options are different, right? Yeah, so what is the percentage of nitrogen? 70, oxygen 27, argon is 4. Okay, sorry, argon is 3. Next, if the total pressure is 1.15 atm, okay, total pressure I'll write here somewhere, 1.15 atm. Okay, then calculate the ratio of the following: partial pressure of N2 to partial pressure of oxygen, partial pressure of oxygen to partial pressure of argon. So this question needs a lot of calculation definitely. So first of all, I should know what's the formula of partial pressure of oxygen. Suppose I want to calculate, that will be equal to mole fraction of oxygen into the total pressure. Okay, and if I want to calculate the partial pressure of nitrogen, because I have to calculate what? Partial pressure of nitrogen to oxygen, that will be the mole fraction of nitrogen into the total pressure. Since the total pressure is constant, we can cancel this one. So I can get that the partial pressure of nitrogen by partial pressure of oxygen is equal to mole fraction of nitrogen by mole fraction of oxygen. Okay, mole fraction of nitrogen by mole fraction of oxygen. So next, what is the number of moles of nitrogen here then? 70 by 28, 2 5 2.5. What is the number of moles of oxygen here? Number of moles of oxygen will be 32 by 27. Okay, 32 by 27. If I solve this, you will get around how much will get? Okay, just a minute. Sorry, 27 by 32. I did a mistake here. Given mass by molar mass, right? So 27 by 32. So you will get some 0.37 something. Okay, 0.37. Now let's see the number of moles of oxygen. Okay, so what is the number of moles of oxygen? Number of moles of oxygen will be 27 by 32, right? So we can divide this one and check how much I'll get. 27 divided by 32, I'll have 0. I think I can take 8 to the 16, yeah, 8 to the 16, 8 to the 24 plus 125. I have 10 minus 6, 4 and 6 minus 5, 1. Okay, then I have 140 here. Okay, so I have 140 here, and this 140 will give me 6 2s are 12, no, 5 2s are 10, 15, 16, no, 4 2s are 8, 4, yeah, 4, 0.84 I'll get something. Okay, so it's 0.84. Okay, next, number of moles of argon I have is, number of moles of argon will be 3 by 40. Okay, given mass by molar mass 3 by 40. So I will just divide this one. 3 divided by 40. Okay, so I will have this one, then I will have 7 4s are 28, then I will have 20, and I have 2, I'll get 0.075. 0.075. Okay. So now we have this one. Okay. So now we have number of moles. So I can calculate first the partial pressure of N2, or first let's calculate the mole fraction of N2. So for that, first of all, I need N total, right? What is N total? We have 2.5 plus 0.84, and then I have 0.075. 5, 7 plus 4, 11, 8 plus 5, 13 plus 1, 14, 1, 3.415. 3.415. Okay, total number of moles is 3.415. Next, I can calculate here. I can calculate number of moles of N2 by the total number of moles, right? So I have here 2.5 divided by 3.415. Okay, 2.5 divided by 3.415, or I can just take it as 3.41. Okay, let's calculate this one. So I can have 25 by 10 into 341 by 100. This one is cancelled. So I have 250 by 341. Okay, I have this one. So I have 8 ones are 8, 4s are 32, 8 3s are 24 plus 3 20. No. So I have 7 0 1s are 7, 7 4s are 28, 2 7 3s are 21, 22, 23. Yeah, I'll get 0.7 something. 7 3s are 21, 22, 23. 10 minus 7 3, 9 minus 8 1, 5 minus 3 2. Then I'll have this one again. So I'll have 0.76. Okay. So next what I will calculate? The number of moles of N2. Okay. I'll calculate next number of moles of O2. Sorry, number of moles of O2. So that is equal to moles 0.84. 0.84 divided by 3.41. So I have 84 divided by 341. Then I have this one. 84 divided by, yeah. So I can check now. We have 2 ones are 2, 2 4s are 8, 2 3s are 6. So I'll have 0.2, 1s are 2, 2 4s are 8, 2 3s are 6, 10 minus 8 2. Then I have 13 minus 8 5, 7 minus 6 1, right? So yeah, so I have now 1480. Can I check with 5? 1s are 5, 5 4s are 20, 5 no sorry 4 1s are 4, 4 4s are 16. Yeah, 0.24 I'll get. Okay, so now can I just calculate this one? That is partial pressure of N2 by O2, right? So 76 by 24. 76 by 24, 0.76 by 0.24, that is partial pressure of N2 by partial pressure of oxygen. Here I have P total and P total, that will get cancelled. So here that means it will become 76 by 24. So I can have 2 12s are 2 3s are 6, 1 18. Then I have 2 6s are 12, 2 19, and 19 divided by 6. So I have here 6 3s are 18, right? I'll have 1, 6 1s are 6, 3.1 or something near to 3. And you see this option is very close to 3. If you do the exact calculation, more decimals, you will get the answer. But this is almost very close to C. So option number D will be the answer. You can check the other two in the similar way. Okay. Next, we'll go to 11th question. Which of the following graph correctly represents the plot of KH at 1 bar and gases in water versus temperature? Okay. So, yes, first of all, KH and temperature are directly related. Okay. If temperature increases, KH will increase. So, in that case, if I see that if KH is increasing, temperature also increases, then which option? Okay. First of all, what all things we can eliminate or see is, you should see that if the solubility solubility is more, then KH value will be less. Okay, solubility if it is more, then KH value will be less, and vice versa. So for helium, if you remember, helium solubility is less, that's why its KH value should be high. Okay, so now if you see at a particular temperature, the KH value of helium should be highest. Now where did we study that? If you remember, when we studied about the application of Henry's law, in the scuba diving we add helium because the solubility of helium is less, so it should have high KH value at any particular temperature. But here you see suppose I take this as a temperature, the helium KH value is the least, so this option is wrong. Similarly, if I consider at this particular temperature, the helium KH value is the least, this is wrong. Now here it is there, here also it is correct, first helium, then N2, then we have oxygen. So this is small printing mistake, this is oxygen. Okay, so helium should, at any temperature you should have helium has a higher value. Okay, now what will happen? Now what happens is, as you increase the temperature, okay, as you increase the temperature, the KH value will definitely increase, but the KH value doesn't go to an infinite value, or it doesn't keep on increasing. Okay, after reaching a maximum value, it then drops down. So that is why this what is the problem in this graph? This graph tells you that at a certain temperature, the KH value for all the three gases will be equal, which never happens. The KH value of every gas is independent. So that is why this option is also wrong. So here you can see that as we increase the temperature, the KH value reaches a maximum value and then drops down. So option number D here. Okay. Next, we'll go to 12th question. This is a very good question again. So here it is all about arranging of equations. So consider a binary solution of two volatile liquids, component 1 and 2. X1 and Y1 are the mole fractions of the component 1 in the liquid and in the vapor phase. The slope and the intercept of the linear plot of 1 by x1 versus 1 by y1. So we need a plot for 1 by x1 versus 1 by y1. Okay, so for this, what all things we can do? See, first of all, I know that what is the value of y1? Y1 is equal to y1 is equal to P1 by P total. Okay, the partial pressure by the total pressure gives you the mole fraction in the vapor phase. Okay, now I know also that P total is equal to P01 x1 plus P02 x2. Okay, so I have this one, P1 is equal to P01 x1 plus P01 x1 plus P02 x2. Okay, that is what? Y1, right? This is equal to Y1, and in place of this I can write like this. Now what I can do is, I just have to see what equation I need. So I need 1 by x1 versus 1 by y1. So I will take this x1 this side and y1 this side. So I will get x1, okay, sorry, just a minute. Yeah, I'll cross multiply this equation basically. So I will get P01 x1 plus P02 x2. Okay, I multiplied this one, divided by, I divide this P01, okay, and into x1 is equal to 1 by y1. Can I take this one? So I just cross taken this one, and then I have divided 1 by y1 on this side. Now can I write this x2 in terms of x1? 1 by x1, x2 can be written as 1 by x1 because there is no x2 term right here. So I'll just further simplify this one like this. P01 x1, okay, plus P02 1 minus x1 is equal to P01 x1, okay, equal to 1 by y1. Okay, so now what I will get here? P01 x1 plus P02 minus P02 into x1 divided by P01 x1 equal to 1 by y1. Okay, so now here what I have, I can take x1 common. Okay, so I'll just start solving here. Okay, just have this one. Yeah, so I have this x1. If I take common, I will have P01 minus P02. Okay, I'll have x1 common, P01 minus P02 plus P02 is there. Okay, whole divided by x1 P01 I have. Okay, is equal to 1 by y1. Okay, what I'll do is I'm multiplying this P01 on this side. So what I will get here is this P01 I have multiplied here. Okay, now if I divide this equation, x1 I get cancel, I'll get P01 minus P02. Okay, then plus P02 by x1 is equal to P01 by y1. Okay, fine. Now I will do what I can. I am very near. I need 1 by x1 versus 1 by y1, right? So I'll keep this term here and I'll take all other term to that side. So I have this term like this: P02 by x1 is equal to P01 by y1 minus this one P01 minus P02. Okay, this minus I am multiplying here. Okay, or let me do it later. Next, I need 1 by x1, right? So I'll divide this P02 also on this side. So 1 by x1 is equal to 1 by y1, and I have here P01 by P02 minus, this minus will be multiplied here, so I will get P02 minus P01. Okay, so I have now this equation y is equal to mx plus c. Okay, so if you see this equation now, I have just a minute. Yeah, now if I solve this equation, y is equal to mx. So what is this m here? M is equal to P01 by P02. Okay, y is equal to mx, and what is the c value, slope value? P02 minus P01. Okay, so this is the slope value, this is the intercept value. So now I can solve this one. Yes, I think I have done one mistake. Yeah, this P02 I didn't divide here, right? This P02 will also be here also divided. So this also has P02. So I have m is equal to P01 by P02. So this I can eliminate, this I can eliminate, and then I have P02 minus P01 by P02. So that is your option number A here. Okay. Next, moving to question number 13. Which of the following binary mixture does not show the behavior of minimum boiling azeotrope? Two important keywords: does not show and minimum boiling azeotrope. So if you remember, minimum boiling azeotrope is shown by positive deviation, right? It does not show positive deviation, means the question is asking about negative deviation. So which of the following will does not show positive deviation or will show negative deviation? Okay, so here definitely we have CH3, OH and NH2. So if you see, there is strong attraction, hydrogen bonding there, so it will have negative deviation. So option number B here. Indirectly asked question, but a good question. Next, we have match the following here: solution of chloroform and acetone. So chloroform and acetone is negative deviation or maximum boiling azeotrope. So I have A for 3. So A3 I can eliminate first, second and fourth option. Let's see the just a minute. Yeah. Next we'll see the second option, ethanol and water. Ethanol and water is a positive deviation. That means maximum boiling, a minimum boiling azeotrope. So B has to be 1 and B has to be 1, and here it is B4. So that is option number A. Okay. Next you can check benzene and toluene. This is an ideal solution. So delta V mix will be 0. So C is equal to 4. Acetic acid in benzene undergo dimerization. So 4D will be 2. Okay, next we'll go to 15th question here. A solution is made by mixing 1 mole of volatile liquid A with 3 moles of volatile liquid B. Okay, so you have a solution is made by mixing 1 mole of volatile liquid A. So what is liquid A, I have 1 mole. Okay, and 3 moles of volatile liquid B. 3 moles of volatile liquid B. The vapor pressure of pure A is 200 and the vapor pressure of pure B is how much? 500. Okay, the vapor pressure of vapor pressure of pure A is 200 and that of the solution is 500, not B. So that of the solution means P total is given to me as 500. Okay, so what is P total here? That is 500. I am not writing the units. Okay, mmHg, mmHg you have to write. Vapor pressure, you have to find the vapor pressure of B. Okay, find the vapor pressure of pure B and the least volatile component out of A and B, which is least volatile, we have to find out. Okay, this is very simple. First, what is the mole fraction of A? Number of moles of A by total number of moles, so 1 by 4, and the mole fraction of B will be 3 by 4. Okay, 1 by 4 divided by, and we have 3 by 4. Now what we have? P total 500 is equal to mole fraction of A 1 by 4 into P naught A is 200. Okay, then I have 3 by 4 into P naught B. Okay, so I have here 4 5s are 20, then I have 500 minus 450, so I have here 450 is equal to 3 by 4 P naught B. Okay, so that will give me 3 into 150 and then I have 600 equal to P naught B. Okay, P naught B is equal to 600. I calculated this value is 600. So I have this option. Now which is least volatile? Very, very important. Least volatile means it will evaporate less. So whose vapor pressure is less? That will be least volatile. So A will be least volatile. So option number D here. Okay. Let's see the next question here. 16th one. The freezing point dissociation of a 0.1 m aqueous solution of monobasic weak acid HA is 0.2 degrees Celsius. The dissociation constant of the acid. So this is a very good question and it has the formula from the equilibrium chapter also involved here. So first of all, we have this 0.2 is delta TF, which is 0.2 degree Celsius. Next, what is molality? 0.1 m. Right, and then we have the dissociation constant for the acid is we have Kf value, which is 1.8 Kelvin kilogram mole inverse. Okay, now if I have this one, delta Tf is equal to I into Kf into m. Now delta Tf is 0.2. okay, I value I have to calculate. Okay, Kf value is 1.8 and molality is 0.1. So I have this one, 2 by 1.8 is equal to I value, and that will give me, if I solve, 20 by 18, I value will be 20 by 18 and I will get 2 tens are 20, 2 9, 10 by 9 I will get. Okay, just a minute, let me just check. Yeah, I will get 10 by 9 as the I value. Okay, now what I have to do? I have to find alpha value. Alpha is equal to what? I minus 1 by n minus 1. Alpha value I have to calculate. I value is 10 by 9, right? Minus 1. N value. HA is dissociating to give you 2 ions. So N value is 2 minus 1, that is 1. So I will get here 1 by 9. So alpha value I got as 1 by 9. Next I have Ka formula here, C alpha square by 1 minus alpha. Now this C is actually molarity, but in the question it is given to us that molality and molarity can be considered equivalent. So I can substitute the molarity value, that is 0.1 into alpha square, that is 1 by 9 square, okay, whole divided by 1 minus 1 by 9, right? I think I have done correct. Yes. Now if I see here, I will get 0.1 this 9 square is 81, whole divided by 9 minus 1 is 8 by 9. Now if I solve this, how much I will get? If I solve this, I'll get 0.1 by 81 into 9 by 8. 9 ones are 9 nines are. So I have 0.1 by 72, or I have 1 by 720. Okay, so now let's divide this one. 1 by 720, I can have here 1 by 720. Okay, let's do, yeah, 1 by 720. Okay, so I have this one 0, 0, 0, 0, 0. Okay, now I think I have to take 1 here. 720, 10 minus 2, 8, 9, 280, I got 2800. So I think now I can take 3, 303, 7s are 21. So 0.0013. So I can see that 3, so this option has to be correct. Option number A, I can see 10 to the power of minus 3 if I take, I'll get 1.3, right? So that's the option number A. Next, question number 17th here. The percentage dissociation of a salt MX3 solution at a given temperature is. You have to find the percentage dissociation. So percentage, first we have to find alpha value. So what's the formula of alpha? I minus 1 by n minus 1. Let's see. What is I value given to me? 2 minus 1. What is n value? For MX3, the MX3, the number of ions produced will be 4. So 4 minus 1. So I have here 1 by 3. Okay. Now what is the percentage of alpha? Alpha percentage is 1 by 3 into 100. Right. So that will give me almost 33.33%. Okay. So this will give me 33. So answer is option number, sorry, here the numerator or the nearest integer will be 33. Next, we will see question number 18 here. Two statements are given. Molar depression constant Kf is given by, so here one formula which I have missed in the class, please note down here. Kf can be found out by R T naught F whole square, R and then molar mass of the solvent divided by 1000 into delta H of fusion. Okay. Now we know that from thermodynamics, delta S is equal to delta H by T. Okay. Now if you see this, delta H by delta TF will give you delta S, 1 delta S I'll get here. So I have Kf is equal to R, then I have T naught F into molality, okay, divided by 1000 into delta S. Okay, R T naught F into M divided by 1000 into delta S. Clear? So this is the statement. So this 1000 will be for unit change only. So the first statement is correct. Kf for benzene is less than that of Kf for water. So Kf for benzene is something 5.12 and for water it is 1.86. Okay. Now you may think that, ma'am, how to remember these values, or do we have to remember? See, when you solve a lot of questions, it will come automatically. You don't have to remember. When you solve questions, in every question the Kf value is given, so you will have an observance there. Okay. So that is why this statement is wrong. So 1 is correct and 2 is wrong. That is option number D here. Next, sorry, we'll move to 19th question here. XY is a membrane. Okay, so this is X and Y. Is a membrane or partition between the two chambers 1 and 2 containing sugar solutions of concentration C1 and C2. And C1 is greater than C2, means this is more concentrated. From then osmosis will happen in which direction? Osmosis has to happen in this direction. Okay, right? For the reverse osmosis to take place, identify the correct option. P1 and P2 are the pressures applied on chamber 1 and chamber 2. Okay. So reverse osmosis. So if I apply pressure on P1, okay, so the pressure that is applied on this side just to stop the osmosis is called as osmotic pressure. But if I apply more pressure, then what will happen? This one will, so this pi is your osmotic pressure. So if P1 is the pressure on this side, P2 is on the pressure on this side. Now if I want to do reverse osmosis, I have to add pressure on this side, that too more than the osmotic pressure. So P1 should be greater than pi. So P1 should be greater, P2 has no role here, okay. P1 should be greater than pi, P1 should be greater than pi. Next, membrane or partition should be there. It can be either a cellophane paper or a parchment paper, any membrane we can use here. So both A and C will satisfy, that is option number C here. Okay, now let's move to the next question. 2 moles of ethylene glycol and glucose are dissolved in 500 gram of water. The boiling point of the resulting solution is, okay, so you have 2 moles of ethylene glycol and glucose dissolved in 500 gram of water. So let's calculate the molality first, okay. So I have here molality of ethylene glycol, number of moles, right, 2 moles divided by mass of the solvent to 1000. So how much I will get this one? 4. And if I calculate the molality of ethylene glycol and glucose, so that is also 2 moles, right, and I have 1000 by 500, that will give me 4. So what is the total number of or I can just write down like this, delta T is equal to Kb into M1 plus M2, right. So M1 plus M2 will be, delta T will be equal to, then what is the value of Kb given to me? 0.52, and M1 and M2 is 8. So that will give me 8 2s are 16, 41, 4.16. Okay. Now what I have here, delta Tb 300 and so I have this one, TF minus 373. Okay, then I will have TF formula, which is 377.16, okay, something. So 377 something I'll get, which is option number B. So students, these were the top 20 questions of JEE 2025 previous year paper, and I hope that these questions are definitely not that easy as KCET, but would have definitely cleared or have given you more clarity about the concepts, how to use the different formulas. And if you have any doubt in any question, do put down in the comment section, I'll address to it. Thank you for watching and all the best, and do not forget to subscribe the channel, because we are going to complete the entire syllabus of KCET in this channel. So if you are an aspirant, definitely subscribe. Thank you for watching and all the best.